back again with another TSA video. In this video, we will be revisiting certain old questions. The one which is the product of array except itself, and I will also be doing some extra questions. Right, so I'll be doing more, more questions, and yeah, that's it pretty much. That's how we roll. And today is just gonna be a very, let's just say, lethargic day because I had to go to an open house which was very early on, which made my sleep kind of shit. So that kind of sucks, but I guess excuses are for losers. Gotta just get the work in. And got my brown noise. Great. So let me just get excalidraw also out here. Okay, so let's try to understand this question and how we can solve this. So given an integer array nums, return an array. I have done this question again, I'm just trying to revisit it. Given an integer array nums, return an array output where output is the product of all elements except this. Could you solve it in O of n time without using division operation? So the way we solve this is, let's say we have an array of A, B, and C, and this is our output array, which let's just say contains 1 at the moment. Now we will do two passes, and those two passes will allow us to calculate the prefix and the postfix. So if you think about it, what is the value that should be at A's position? It should be all the elements. So all elements in the prefix, that is before A, multiplicated into the elements after A, which is the postfix. So if we do one pass through over here while assuming the prefix to be 1, so now we have A, so A's prefix is 1, then we come to B, so we multiply prefix into this, so now B's prefix all multiplied is A, so we put A over here. Then we come to C, C's prefix is B into A, pretty much multiplied it, and we go B into A. And then we do a pass through here calculating the postfix, right? So the postfix of C is 1, so we do into 1, right? And B into A is already here, into 1. Then we do over here, so we'll do C, so here we'll just do into C over here. Then we come to A, which is B into C, and we go B into C, and then we get the array with all of the requirements. Now how do we translate into code? So we'll do quite simply, we'll do prefix is 1, we will do prefix postfix is equal to 1 comma 1, right? We'll just do that. Is there any format code? Oh, there is format code option, right? And then we will do output array. I will just say out array, which is gonna be 1, and it will be length of nums. And I think, you know what, let's just do length of nums as length of nums, so we don't have to recalculate it every time, L. And then we do the first pass through, so we'll do for I in range of L. So the way we calculate this is, we will essentially say out array of I is equal to prefix, and prefix is equal to nums of this. So the way this works is, right now this will be 1, right, which is at the moment prefix is equal to 1, and then prefix will be into star, prefix equal to prefix into nums I, which is at the moment A. So now coming forward to B, we will have A into this, right? And then we'll have A into B, and then coming over we'll have A into B. Now while this is done, we will do for I in range of L minus 1 minus 1. So this will start the count from 2 1 0, because this is actually 0 1 2. I'm going to start from here pretty much, and actually going to start from minus 1, because yeah, that will be starting, it won't be including minus 1, it won't include minus 1, but it will include this. So we will do L minus 1, and we will do out array I is, actually we'll do this as like this, whatever is into this into the postfix, and the postfix is nothing but postfix into whatever nums I consist at that point. And then finally I will return the out array. So this makes sense. Actually, you know what, I'll change that code so it's much more readable. Prefix is equal to prefix into nums I. Yeah, makes sense. So prefix equal to prefix into nums I, so that keeps on p में आया तो पहले उसको दिया a का, and then okay. Then you know, for I in range over, let me just format this real quick. Out array, I think this should run. Okay, let's submit. Let's see if this works. Okay, so this does work, which is great, and it's good to know that I'm able to recall the solution, and this solution makes sense. Righty, righty. Yeah, let's. I think the next logical step would be to finish two pointers. Yeah, so we had valid palindrome, which we did in stream. We had container with most water, which was again a very good question. The only question that is left is three sum, and I think I try to get the habit of doing this in actual LeetCode side. Um, yeah, but sure, we can do it in both of them. I think I've solved this in LeetCode. Yeah. Do some dick shit over here. Yeah, let's just say I never had good language. Yeah, but that's not how you do it. Actually, let me just remove this. This is bad code. We'll figure this out. Right. So I looked at the NeetCode video of it, and I did understand it in a sense. Like I was able to figure out how it was supposed to, because if you guys recall, I did this video on stream, and in that video it was mentioned how you need to solve two sum two in order to like understand how this is done, right? So yeah, I think we'll do that. So given an integer array, nums return all triplets such that I is not equal to j, I is not equal to k, and j is not equal to k. Okay, pretty much not all of them are equal. This, notice that the solution must not contain duplicate triplets. Hmm. Minus 1 0 1 0 1 minus 1 minus, so it won't, yeah, so it won't contain this because it's minus 1 0 1 minus 1 0 1. Notice that the order of the output and the order of the triplets does not matter. The order of the output and the order of the triplets do not matter. Okay, so the which order I give this out or in which order the individual triplets are does not matter. Hmm. Okay. Hmm. Okay, so let's start this, I guess. I'll try to recall as much as I've learned from his videos, but I don't know, I'm going in blind on this one. So okay, so we have minus 1 0 1. Okay, so if I choose this, and again, what is the time constraint on this? O of n square time and O of n. Okay, O of n square. So if I choose this, and okay, so I have minus 1 chosen, and okay, okay. Hmm. Like if I start from minus 1, okay, and I try to look for a target. So I think the way he said is, okay, so we have minus 1, right? But the thing is, the way he said that approach worked is that the list is sorted, but the list over here is not sorted. Did he meant we'll sort it? Huh? Because wait, let me look at the neat code solution for the neat code side. I mean, I could do that thing where I could sort this. So if I sort this, it will be 0 1. Okay, actually, to be honest, if I sort this, it will be minus 1 minus 1 minus 1 0 1 2. Actually, yeah, minus 1 minus 1 0. Yeah, I think this is fine. How do I? Okay, Okay, let's see. I'm gonna minus 4 and this done. This done. This done. Okay, so that's done. Okay, so if I sort this and if I choose this, right now I have minus 4. And so in order to get this, my target should be 4. That is my target value essentially. So now I can start a left pointer and I can start a right pointer. And if I can find this, then it's greater because then that means I found it. And then I can do over here, over here. I think that's what the solution was. If I recall correctly, he said pretty much he sort the list. So you would have something like and also it's funny because he said and in O of one space. O of one space is interesting. Okay, but we sort it, right? And we sort this. And then we start a left pointer and we start a right pointer. And if we just check if anything enters, anything gets us the target of 4. If it doesn't, then well, that kind of sucks. And we just say, okay, fine, that does not give us, then we'll just go ahead and try with minus 4. And we'll try this left pointer and this right pointer approach. And now you may be asking, Natik, why are we not considering this minus 4 over here? And that's a very good question because if we have A, B, C, which is equal to 0, we need to get A, we need to get B, we need to get C. So if we add A on this, when choosing this, this could very well be B as well because no other solution had B. I think now what will happen is if we were to choose this as our A and try to find our remaining B and C, and then we had this as our A, so that now our A's are repeating. Now you might be saying, okay, well the A might repeat, but the B and C may be different because if you have minus one, you have like I don't know, like some possibility of B getting different or something. Um, the thing is, I have seen the video partially, so now I'm thinking whether I should watch it fully or should I just try to guess what it was, which is not that productive. So, because the question said we do not want identical triplets, right? The sense things are that I, J, I think this is wrong. Hmm. So we have sorted it. So we have already taken n of log n time to sort this, unless they're doing some form of bucket sort, which they can, I mean. But okay, let's say this is n log n in place sort, and we take this pointer and we start from here to here. So if we take this, this becomes our, so to speak, our A, right? That is fine. That can become our A. And if we choose this our A, then we can take this entire canvas as left and right pointer. But we have to avoid this. Okay. And if we take this as our A, then I mean, but the only thing that is same will be the A value. B and C, there's no guarantee that will be the same. Okay, I'm gonna do something very different. I'm gonna watch the video explanation because I feel like just pondering around will not lead to anything fruitful. Maybe I'm wrong, but I guess I'll just watch the video, try to understand what's happening over here. I mean, yeah, so I mean, if you take this as an A, then possible B's are this, this, not this. But if you take this as a B, then possible C's are this, right? Same thing over here. If you take this C, 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 even this C, 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 right? This becomes that roughly. And then if you were, yeah, I mean, okay, whatever I said was right. I was just thinking, all these questions I did, I have to make a list of doing these questions again so they don't leave my memory. But the most important thing is, and I think that everyone needs to know, is you need to understand the concept rather than just mugging up the solution, even though it's very tempting to just mug up the solution. In the last stream, I did something very messy. I think it was regarding longest consecutive series where I used a while loop. Who have watched the video would know about that. But instead of just relying on that, I try to solve it. Like, okay, why did that happen? And I figure it out. So I feel like that's okay. You know what? Actually, I'm just gonna allow a little bit of sound, not a much, but just a little bit. See how much it is.
Right? But that's not what we want. We want to eliminate the duplicates. So the problem was we took -3 as our A value, right? And then we searched the rest of the array for two numbers, 1 and 2, that add to 0. But then we went back here, right? And we found the -3 again, and we did the exact same thing. The problem is we don't want to have the same number in this position, in the A position, twice, because then if there are the numbers that come after it, we could potentially find duplicates. The solution to this problem is to sort the input array. Let me show you what I mean. So here you can see that the array is now sorted. Let's cross out our top array, which was unsorted. So now if we find -3 first, then that's good. Okay, we'll say -3, then we find these two numbers, 1 plus 2, and then we find our solution. Great. Now if we get to -3 again, we'll say, hey, wait a minute, this number was already in this position, right? And we know that because its neighbor, its left neighbor, is the same value. We don't want to put it twice here because if we do, we'll get the same duplicate. So we're going to tell ourselves that we already computed all combinations that start with a -3. So we don't need to do that anymore. We already visited this one. We're going to skip this one, and then we're going to go here. So that means in this case, we're not going to find any more results in the remaining portion of the array because they're all positive. They're never going to sum to 0. So then in our result, we're only going to have the one triplet, -3, 1, and 2. We eliminated duplicates by not reusing the same element twice. I think it helps to understand a little bit about the statistics of like combinations and permutations to like understand exactly why this eliminates duplicates. But I hope this explanation at least helped a little bit.
Yes.
So now that we know to sort the input array and we know how to eliminate duplicates, once we find our first number, notice, right? So let's say we have -3. So then the remaining part of the problem, there's only two elements, right? So it basically reduces to two sums. And you probably know how to solve two sum, right? Obviously, we can put the numbers, let's say that this is our first A, right? So then for the remaining portion, we're basically going to do two sum. And we can do that with a hash map or a hash set. But if you solve the problem two sum 2, you know that we don't need to use a hash map. We can use a left and right pointer.
Yeah. So for those who don't know Tourism 2, go watch it out. I have a video on it, and pretty much that's how he does it. This was the video for the reason why I made Tourism
So
2.
this is our left. this sum, though, is too big, for example, if our sum was greater than 0, we want to decrease our sum. Now, we can do that by taking our right pointer and shifting it. So our right pointer would be shorted. So our sum is too small because the input array. Shift our pointer once more over here. We don't want, in that case, we don't want to reuse the same. Remember, we are sorting the array, which is big O of n log n. And then we are not doing the brute force is sorted to our advantage. That would be n.
So we're doing every array, we're checking n. For each n, we're doing another n operation, so it's n squared.
O n squared. So that means obviously the time complexity reduces 1, or it could be big O of n, because sorting actually does take extra memory in some libraries. So it depends on your implementation of sorting. Remember, we have to return this result as a list of lists. And remember, the first thing you want to do is sort the input array. Next, we want to use each number in the input array as a possible first value. So I will iterate through the index and the value. And remember, we don't want to reuse the same value in the same position twice. So if I is greater than 0, meaning this isn't the first value in the input array, and this value a is equal to nums of I minus 1, that means it's the same value as before. That means we want to continue. We don't want to reuse the same value twice. So we're going to continue to the next iteration of the loop. Next, we're going to use our two-pointer solution for the remaining portion of the array to basically solve two-sum. So we'll have left and right pointers. Left will initially be I plus 1. Right will be the end of the list, length minus 1. Left and right can't be equal, so we're going to say left is less than right. Now we're going to actually compute the sums. So we'll say our three-sum is A plus nums of left plus nums of right. So if the sum is too great, remember, if it's greater than 0, which is what we're looking to the course, we have to add it to our result. So to our result, we're going to append all three numbers. So the numbers are A, nums of left. But how do we update it? There's a lot of ways you can do it. Now, of course, we got to update our pointers, but how do we update it? There's a lot of ways you can do it, but I'm going to show you the way that you can do it with writing the minimal amount of code. So let me just write a comment to show you a little bit. What if we had the two-sum basically for these left and right, and we were at -2, -2, so -2, 0, 0, 2, and 2. What if our left pointer was here and our right pointer was here? In that case, we found a solution, let's say, right? Then we'd want to update our left pointer, right? So then our left pointer gets to -2 again. But that's the same one as before. So in that case, we want to update it one more time to get it over here, right? Now in that case, now our sum is going to be too big because we're going to be at 0 plus 2. So that's greater than 0. So then our loop is going to execute saying that this is too big, and we're going to shift the right pointer to the left. But notice how that right value is now the same as it previously was too, but that's okay because our sum is going to evaluate as too big, so our right pointer is going to be shifted again. Notice how each value is only going to have one corresponding value that it can sum equal to the target, which is 0. So we only have to update one pointer, and the two conditions
Okay.
will update the other pointer by itself. We don't even have to worry about it. So in this case, we're only going to shift our left pointer because we don't want to have the same sum.
That did not make sense. Okay, I don't understand this at all.
We're going to have to use a loop past the right pointer, so we're going to add that on the first try. Let's see. We passed the test case, the first test case. so it did pass. Usually I have some stupid bugs where I mess up a condition, but okay, so I might have made easy with the amount of code I wrote, but don't let it fool you. I really struggled with this problem the first time I was doing it, and you can see here the
Wait, but I don't understand at all. So I'm just gonna like put my hand down and try to understand this again. So he says sort this up. So he says -3, and this becomes our a value, and then we check, we do like left and right, which makes sense. Like I have no issue with this. Um, but then he says don't do -3 again, because you would have pretty much checked all of the possible combination, and you will see over here when you, okay, let's look at this code. Yeah, so you see for I comma a, if I is equal to 0, obviously, and a is equal to, because if it's the same, then we just don't do anything with it, else L becomes I plus 1. So this becomes essentially, this becomes our L, and this becomes our R. Hmm. And then we do while L less than R, 3 sum A plus nums L plus nums R, 3 sum is greater than 0. My question is, I mean, ठीक है, यहाँ से यहाँ there's no difference because we would be calculating that, but how is he saying कि you have calculated all the B and C combinations of this automatically? Um, because in my mind what I'm thinking is, while we were doing -3a, this -3 had access to another -3 as a potential value, but when we do -3 of this thing did not had -3 as a potential value. So how did it check all the possible combination, right? By the very definition it has to check all the possible combination, but this does not have access to -3 now, right, as per the code change. So now I'm a bit confused, and then in the middle of the code he says, okay, well, this makes sense.
at negative value. Case, if nums of left is equal to nums of right minus 1, that means it's the same value, so we have to keep shifting our pointer. But remember, we don't want our left pointer to ever pass the right pointer, so we're going to add that to the condition. So this is all we needed to do, and now I believe, unless I've made another stupid bug, we
Wow, I mean, I'm very tempted to watch this video, and but you don't should not do video hopping. It really does read things, you makes you waste your time. But I think I'll just force some also.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So
What
what
are we
did we
doing
do
at this
in
point?
a sorted order? Because we took a sorted array, you had I at the left, you had J in the middle, you had K at the right. So it is already in the sorted order. Got it? Next, you are at 0. What can you do? You know this cannot be taken, and this is where the optimal solution comes in. So in both the brute and better solution, we were using something like a set data structure, which was helping us to get all the unique triplets because it was filtering out all the duplicates. Plus array of k. Okay, this is what I'm looking for. This time what I'll do is I'll say, hey, this I'll probably fix the I. So what I do is I fix the I over here. Okay, and now I'm looking for J and I'm looking for K. What I know for sure is this is entirely in a sorted order. This is entirely in a sorted order. So I'll probably keep the J here and I'll probably keep the K here. Okay, this is what I'll do. Initially I will be fixed here and J will be kept at 1 after I, and K will be kept always at the end. Perfect. Now what I'll try to do is add up these three elements. Let's try to add it up. Minus 2, and 2. So if I add it up, what will I get?
Minus
I'll
two.
get a -2. And what was I looking for? If you remember, I was looking for 0. So I'm getting a value which is lesser than 0. So if something is lesser than 0, what do I need to do? Remember, I will always be constant, I will not move. What do I need to do? In order to get near to 0, I have to increase the value, I have to kind of increase someone's value. And if this is constant and these two can move. How can I increase the value? If I go this way, since the array is sorted, hear me out properly. Since the array is sorted, the values will decrease. The values will decrease. The minus 2 will go down. I need to increase minus 2. I need to increase the value of minus 2. So what I will do is, I will move this element. Yes, I'll move here. And even if I move here, it is still minus 2. I'm like, I still need to increase it more. I'm like, okay, you need to increase it more. Let's go to minus 1. Minus 1. Slightly increased. Further. Further. There's 2. I am getting the 0. So what I did was, I just kept on moving and I tried to reach near 0. And happily at this moment, I have I have one I have one J, and I have one K. That is one of my triplets. I'll probably store it. And I know the triplet is very simple. It's minus 2, 0, 2. It's already in the sorted order. If you carefully see, it's already in the sorted order because you took a sorted array.
Yeah, because the relative positioning of I, J, K will be that I will come before J and J will come before K.
You had I at the left, you had J in the middle, you had K at the right. So it is already in the sorted order. Got it? Next, you are at 0. What can you do? You know, this cannot be taken, this cannot be taken any further. So what you will do is, you will simply move both of them. And the moment you move both of them, it will come over here. And this time, this K will come over here. A careful thing. If you just move it by one place, what will happen?
Okay, so he said move it by one place because you have practically checked this with respect to K and with all of that. So that's why you're like, okay, we can't use this because we have checked it. But then you can always move J ahead without changing K, but he changes K as well, which is interesting.
Happen is, you will again end up taking minus 2, 0, and plus 2. You need to you need to avoid this because we need to make sure we just store the unique triplets,
Unique
identical
triplets,
triplets. So
identical,
what
yeah.
you will say is, I moved it one place, but I should not move it one place. I should actually move it more. I should just move it out of 0. I'll not take 0. No further 0. I'll not take 0. I'll move it out. I'll be like, okay, let's move. What is the place where there is no 0? That's this place. Perfect, I'll move it. And for K, I'll be like, I was here now. There is 2. I'll not take 2. I'll not take 2. Move it, move it. So I will move it. And if I try to move it, what will happen? Where will K will be here.
K will come before
The
J.
moment J and K cross,
The loop
what
stop,
happened?
loop
I
stands.
firstly assumed I to be your left, J to be your mid, and K to be your right, so that they always are in sorted order. Okay, I've moved it. It's no more in the sorted order, so you stop. Yes, let's move. Perfect. Stop. Next, this I, which is constant, will try to move. Again, there's a catch. If this is minus 2, you again don't take minus 2 because you'll again generate the same triplets. So you move to the element which was not minus 2. So the moment you try to move to the next, you'll be like, hey, wait. You were equivalent to the previous. No, go ahead. I've already done. I move here. And he's like, hey, you were equivalent to the previous. No, go ahead. And then I stop at minus 1, which is not equivalent to my previous. Let's stop at minus 1. So this is my, as of now, I. Perfect. I this time started J, which is here, and K will again be here. Amazing.
Okay, a little bit understanding is inside my mind, bro. What is bro? What's bro on? Okay, yeah, so minus 2. We don't check this. Come over here. I mean, yeah, sure, but I don't understand that logic still now.
So
Like,
minus 1, and plus 2. This is where I start. So I got a minus 1, I got a minus 1, and I got a plus. So what I'm saying is, aren't they giving me 0? They are. They are giving me 0. So this is one more triplet, minus 1, minus 1, 2. So I take this triplet, and logically, I should have moved this by one place.
but then
And
again, we
again, I
don't.
cannot take these guys anymore. I should have moved the K by one place. Logically, I should have done this. But I know cannot take any further minus. So I'll be like, oh, you are still equivalent. And it'll stop here. And I'll say, still 2, move. It stays here. Perfect. Now, what happens? Where are we? Minus 1, 0, 0. What's the value? Minus 1. It's lesser than 0. What do I need to do? I need
Ink.
to increase, I need to increase. Still the same, so I'll still done and dusted. So I'll try to move it. When I try to move it, it says, hey, you are still equivalent to previous.
Okay, so I get that part. I guess the moment they have reinforced it, so I guess something would be something like for IDX well enumerate nums, like something like that. Wait a minute. And so इसे हुआ ही नहीं हुआ. Okay, so result is equal to this nums dot sort for idx val and enumerate nums. Print. Let me just print for my own sanity check. Okay. Yeah, so the thing is we don't want to check the first element because the first element will be unique, and so we'll just check if idx is greater than or greater than 0, then greater than or equal to 1, and nums idx is not if I is greater than or equal to I, because we don't check for that. We need to make sure that is equal to nums I minus 1, then only we take care of val. That will make sure keep. So as you can see, we have minus 1, so while I is greater than equal to 1, कुछ तो गड़बड़ है भाई, कुछ तो गड़बड़ है. ओके my bad. I'm so down. Sorry, that's much better. Yeah, so again we don't include minus 4, which is dumb. If I is okay, ठीक है, greater than 0 and nums I Okay, understood, that makes it. So if I is greater than equal to 1, क्योंकि हम लोग उसके लिए चेक कर रहे हैं, I equal to 0 चेक नहीं कर रहे हैं, and nums 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 I um, nums nums I minus 1 is equal, then we continue, we don't care. This is the, so our left pointer becomes I plus 1, our right pointer becomes length of nums minus 1, and while LP is less than RP, um, we'll do something like nums LP plus nums RP plus nums I, right? Nums I essentially, this is our 3 sum. So if 3 sum is greater than 0, so we have to decrease it. So we'll do this, right? If it's greater than 0, then we have to use this. And if 3 sum is less than 0, we have to um, do that. And else if it's equal to this, then we will essentially just do result dot append, and because that will be in the same order, LP and RP. Okay, so let me just put this code in while also reciting it in that sense. But yeah, pretty much what it will entail is if I is greater than, or in this case, greater than or equal to 1, and nums I is equal, if nums I is equal to nums I minus 1, then we will just continue because we don't really care about it. And if I format this code, that's what we do basically. If it's equal, we don't really care, but if it is, we'll do L is equal to I plus 1, because we don't really consider that the first element is considered as our pointer. It's length of nums minus 1, and while LP is less than RP, we will do 3 sum, which is equal to nums I plus nums LP plus nums RP, and we will say if 3 sum if 3 sum is greater than 0, right, because this is constant, right? If it's greater than constant, if it's greater than equal, we'll do that. Else we will do so elif 3 sum is less than 0, then we'll do L this, and else we will do rest dot append, and so we have to append the actual values, right? Nums, we have to actually append the actual values. We have to actually append the actual values, chat. Minus 1 0, yeah. So nums LP nums RP. Let's format this code much better. So res is another way we have to return res. So right, this is inside that. Anyhow, so res is equal to an empty nums dot sort for idx val, if, because we already say okay, this is a is repeating, and then it will pretty much need to duplicate. We do I plus 1. It will break the loop essentially.
I've already done for you. Move.
And I think he tries explaining that part before this,
And
and
the list, length minus 1. On the other hand, if it's too small, we need to make the sum bigger. If only I could type today.
what am I doing over here, chat? What am I doing over there, chat?
If it's too small, we need a case is it we're gonna append nums of right.
Oh my god, that's so dumb. Yeah, I could pretty much, because I have already have access to the values. I can just say valve, which makes sense. Yeah, that's so dumb. Yeah.
Now, of course, we gotta update our pointers, but how do we update it? There's a lot of ways you can do it, but I'm
Okay. The moment he said how do we update it, it actually clicked for me. Okay, this is left. and this is right. And so if the next element were in the same thing, same, we wouldn't want that. Like we would want our left and right pointer to point to new distinct elements. It could either be the left pointing to a new element, or it either could be the right pointing to a new element, which I'm context switching on too much, which I don't like a lot.
I'm like, hey, still, move. Hey, not equivalent. Move equivalent. So this time, start J here, have K here. Again, very simple stuff. 0 plus 0 plus 2. What's the value? 2. Greater and num of I is not equal to num of, or you can say equal to num of I minus 1. That means it's equivalent. We will say, please go ahead and continue. Continue means it will not go down. It will just go here and do the next step. And if it is not, then I go down and do all the steps. Continue clearly states, do not go down, go back to your for loop, increase I and do the next step. So I know if it is equivalent, I'll keep moving the no, and just keep them moving. And I know there will be three conditions. What will be the three? Plus is lesser than 0 is other. Pure increases. So what now I will do is, and once I put them up, I know they will directly go into this answer. Do I need to sort them? Think on that. No, it's already in the sorted order. I'll just go and say push back temp. Amazing. Now, what is the next job I do? I know J and K cannot be seen, so I'll just move them one ahead, and I'll also move this one back. So if you remember well enough, we had a minus 2 as the I. We had
Yeah, so pretty much what he's trying to say is that it makes also sense. If we do else, well, LP and RP still remain the same, right? Because if you imagine, if we find them L and R, well, they give us 0. But by this standard, we're not doing this, and this will go into an infinite loop. So we have to be do something like this and RP minus 1, because they'll be in the same loop, right? They'll keep on doing it again and again, and time will exceed. And I can show you that that's the case. I mean, first of all, this won't pass the test case, but this is will just exceed the time, so to speak. So we have LP plus 1 and we have RP minus 1. I think he will do a for loop that while LP is equal to its previous LP value, we just keep incrementing it. Um, so okay, sorry, it's my bad. Just
this one as the K, and we had this one as the K. And after that, what we did was we moved J by one step, and we moved K by one step. But if we do this, what will happen is in the next step, this 0 and this 2 will again form another triplet, which is wrong. I don't want that. So what I'll do is I'll move it by one step. Then I'll check, is it equivalent to the previous? It is. So move it by one step. Is it still equivalent to the previous? Yes, move it by one more step. Keep moving till it is
that's why
equivalent.
NeetCode says you can either change either left or right pointer.
Equivalent to the previous because it matched. So I'll keep it moving till num of J is equivalent to its previous. Keep moving. And at the same time, I'll say, hey, listen, none of what K is equivalent to its. So over here, K is at this.
Interesting. And the way NeetCode does it, he just only updates. Let's just see what he updates actually. So he only updates the left pointer in the hopes key, and it keeps updating it while it changes it. I think I'll go with that approach, to be honest. So I think I like that approach much more. To be very much honest. Like so we say LP plus 1, and while nums LP is equal to nums LP minus 1, right? That's how it works. LP minus 1 and L um, what am I doing? I just LP plus 1. Okay, so while nums, because we have incremented it, and do we need to do this? I mean, that's the reason why I was worried, because if we don't do this right, this code might go on forever, and this will give us an index out of bounds error, and the only way we can prevent it is if we use RP as a safeguard. Um, Pretty much. Runtime I is not defined. Um, Let me just run this test code once. Let's see if it passes. Oh wow. 600. Okay, let's see this one more time whether it was just like LeetCode being naughty. Oh, it increased it. Interesting. Three sum. Um, yeah, so there's something wrong with their Yank implementation. To be honest with you, seems like there's something wrong. Like there's something wrong with it. I don't know, there's something is wrong with it. But okay, let's try to. I have some understanding of what is happening. So obviously this line makes sense because we don't want to as consume the same A. This line makes sense. We're basically doing two sum two, where we're just seeing this, and else which is this makes it a more interesting. Because we first of all append this and no need to obviously sort this because we know by the relative ordering that they will be sorted. LP plus equal 1. So you can actually change RP as well. This solution, the one by take you forward, what he does is he just makes, you know what, let's change both J and K. But in this solution, as he said, he wants to write the code with the most minimal amount of lines. It's where we just only take the charge of changing the pointer at LP. And I think the worst case would be key LP वहाँ जहाँ पे है, it's like this is L and this is R and L keeps changing and it passes this. And the issue with not having this statement, and I feel like he's not having that statement, is going to be an issue.
Right out of, because if it process were done and I'm
Uh,
not going to just keep on doing this because it might run out of boundary. So this is why just make sure there is a
yeah,
simple case.
yeah, that's the thing. So because the thing is, right, it will keep just checking this, but it won't really check this. And even though this is involved, this loop has to terminate by itself in order for this loop to, terminate it if it did something like that. So yeah, this makes sense. It will take me some time to like maybe internalize this. The confusing part for me right now is the fact that he says ki we don't take these to the common, because if we take them to common, they will. It's pretty much them saying ki, if this is A and you have A over here, we have to basically ignore this because we have already tried out every combination whatsoever. Okay, okay, understood. I guess I have just spend more time with this question to understand this even more. I have certain doubts with this question. I wouldn't say it's complete in my own mind, but yeah, this part is confusing. This part makes sense, but this part is very confusing, to be honest. Okay, I guess that will be it for today. I guess this is one lead code question that actually kind of bothered me for a while. And with that, I think we have covered our two pointer as well. And I think we might be going with binary search as well, because you never know. I like binary search. Sliding window also seems cool. Then we also have a linked list. Linked list I might do. I might like linked list. Yeah, I guess that will be it for today's lead code slash NeetCode grind. See you tomorrow. And yeah, I I guess I'll upload one more video tonight for I doing GitHub Actions, CI/CD with my fast API. I did Docker, and I'll now do CI/CD as well. I think that's a natural progression. See you till then.